Are you ready? So class, activity 2.31b. So we're in activity 2.31b. We're asked to classify the following functions according to their types. We have I, f of x equals to x raised to power minus 3. I, g of x equals to x raised to power 1 over 5. I, h of x equals to x raised to power minus 1 over m. IV, k of x equals to square root x minus 2, everything raised to power 3, all over x minus 3. Class, we are asked to classify each of the following functions. Now when they say classify each of the following function, that means they mean to classify them as either even, odd, or neither even nor odd. So class, the good thing about this exact question is that they have been repeated in your Math 101 manual. And we already solved this last week, but I'll still take one or two of them so you can see how to approach this question. So I'll take the first one, I. It said f of x equals to x raised to power minus 3. Now do not forget the condition for a function to be even. So we are going to check in each cases if the function is even, odd, or neither even nor odd. Now based on the space they gave you in this manual, you won't be able to show everything in this manual. So what I advise you to do is that you take a rough sheet and confirm first. Then what you fill in your manual is the one that you found out that if I find out this function is even, then I'll say the function is even and you show the reason why it's even. If you were to do even, do odd, then do neither even nor odd, it takes so much time. So you do for even first, you do for odd, you do for neither even nor odd. Do it in a rough sheet. Then when you find out that it's even or you find out that it's odd, anyone that is actually applies to this, you now write it in your manual. You understand? You can't write everything in your manual, it takes, the space is not enough. So we're going to do it in your rough sheet, so please take notes. Don't forget the condition for a function to be even is f of x equals to f of minus x. And the condition for a function to be odd is even. And the condition for a function to be odd is that f of x must be equal to minus f of minus x. So let's check, is this function even or odd? Or neither even nor odd? Or neither even nor... Actually, I've solved this before. I think we got odd, I think. I'm trying to... You got odd, class? Yes. So, you see, now, because I know that it's an odd function, I might not need to do even again. Even if we know what to do, that's when it's even. But let's still do even and see. To check if it is even, to check if function is what? If function is even, what do? We find f of x, which is x raised to minus 2. Let's go and find f of minus x. Let's find f of minus x. And is it the same thing as f of x? Now don't forget, to get f of minus x, it means anywhere you see x, replace with minus x. So instead of x raised to power minus 3, it's going to be minus x raised to power minus 3. This is how you get f of minus x. Class, make sure you are following. Make sure you are following. If someone online can get it, then you that is looking at me here should be getting it better then. Minus x raised to power minus 3. So we are going to say, how can we expand this bracket? Class, according to the law of indices, we're going to use the negative index law. The negative index law. Anytime your power is carrying a negative, this negative can disappear as long as this becomes a fraction. This will now become 1 all over minus x raised to power 3. Notice that there's no longer negative. Because minus x raised to power, this has come down, so the minus has disappeared. Please, this is the minus that disappears, so the minus with x does not disappear. Please take note. Now, let's expand this bracket. This is 1 all over minus x in 3 places. Minus x raised to power 3 means minus x in 3. That's minus x, another minus x, another minus. Now, minus times minus is plus, plus times minus is minus, right? So we have 1 all over minus, because minus times minus plus, plus times minus minus. Now, x times x squared times x raised to power. So class, the final answer is 1 all over minus x raised to power 3. This is f of minus x. This is what? F of minus x. Class, you can clearly see that it is not the same thing with f of x. Even if we bring this x raised to power 3 up, it's not the same because of this minus sign. Class, 1 all over minus x raised to power 3 is the same thing in a fraction, class. If your denominator has a minus, that minus down can still go up. Class, 1 over minus 2 is the same thing as minus 1 over 2, class. For fractions, for what? So 1 over minus 2 is the same thing as minus 1 over 2. So it means that 1 over minus x raised to power 3 is the same thing as what? 1 over minus x raised to power 3 is the same thing as minus 1 over x raised to power 3, right? Now, if x raised to power 3 comes up, it becomes x raised to power minus 3, right? When it comes up, it acquires a negative sign back, right? Now, class, but don't forget that there's a minus up before. So with this minus now, our final answer is actually minus x raised to power minus 3. And it's not the same thing with f of x, which is just x raised to power minus. Our f of x does not have minus. So this function, therefore, is not even. It's not what? Even. But you won't have to show this in that small space. They say classify the following function, right? So do all the rough things in your rough work. Then when you now find out what the function is what the function is you now write in your manual. Are we together? Now continue. Now, so let's find out if the function is odd. Let us find out if the function is what? Odd. Now, we'll use the second criteria. For a function to be odd, f of x must be equal to minus f of minus x. For a function to be odd. So, thank God we already have f of x. Let us just go and get minus f of minus x. For class, minus f of minus x. First of all, what is f of minus x? Before we find the minus f of minus x. We just did f of minus x now, right? We got minus x raised to power minus. So what is now the negative of this? Minus f of minus x is minus into bracket under minus x raised to power what? Minus 3. So what is this minus times minus? Plus. So we now have plus x raised to power what? And it's clear that this minus f of minus, and it is the same with f of. So f of x and f of minus x are the same. Therefore, the function is what? Odd. Okay, how do you write therefore in mathematics? You don't need to write therefore in what? Therefore, you say since f of x is equal to what? Minus f of minus. You now say therefore, this is what I'm actually showing well. Therefore, f of x is equal to minus f of minus x. Is equal to minus f of what? Minus s. This is the approach you also apply. So you see that you just classify the function. You say function is even, then prove it. Don't need to show the odd part. You don't need to show the other part. Just say function is odd. Function is what? Odd. And you show the why you say it's odd. Because say classify the function, right? Say function is odd, then to show that the function is odd, you now do this. And then you say since f of x equals to minus, you are doing your reason now. Since, therefore, f of x. Since f of x equals to minus f of minus x, therefore the function is odd. Therefore the function is odd. It's an odd function. So you can see an example of what you do. So that's what you still do for this guy, I. Please come. For I, you have g of x equals to x raised to power 1 over 5. So for this function to be even, g of x must be equal to g of minus x. For the function to be what? Even. Let's start with even. For a function to be odd, g of x must be equal to minus g of minus x. For a function to be odd. Let's check if it is even first of all. Class, we already have g of x, so let's just go and get g of minus x. G of minus x, class, means anywhere we see x, we put minus. So this is now minus x raised to power 1 over 5. Minus x raised to power 1 over 5 and x raised to power 1 over 5 are not the same thing. They are not the same thing, of course. So, class, the function is not even. But let's now also go and get minus g of minus x. Minus what? Means minus of this, right? That is minus into bracket minus x raised to power 1 over minus times minus plus. So this is now x raised to power what? And it's clear that the function is odd then, right? Because you say since what? Since g of x equals to minus g of what? Minus x. You say therefore g of x is what? Is odd. Is what? Is an odd function. G of x is an odd function. Class, You see that you apply the same approach here, apply the same approach. Yeah, just classify the function. Say classify either it's even or odd. So far our first function was odd. Our second function is also odd. Let's take a look at our third function. I. You're still there, right? Now I say h of x equals to x raised to power minus 1 over m. Class, even function means that h of x must be equal to h of minus, then the function is even, right? When is it odd? H of x must be equal to minus h of minus, then the function is odd. Class, we already have h of x. Let's get h of minus x. H of minus means anyway we see x equal minus. So we're going to have minus x raised to power minus 1 over m. Same thing as 1 all over minus x raised to power 1 over. And this is actually, if I want to break this down very well, this is 1 all over m root of minus x raised to power 1 plus x raised to power minus x raised to power 1 over m is m root of minus x raised to power what? 1. M root of minus x raised to power 1. This is h of minus x. And it's clearly not the same. If I was to do this, I would have h of x. If I'm to break h of x down, it's going to eventually give me 1 all over m roots of x raised to power 1. This m root of x raised to power 1, but this m root of x minus x raised to power 1, they are not the same. So the function is clearly not even. Let's go and find minus h of minus x. Means that h of minus x already is 1 all over m roots of minus x raised to power. Now another minus here means there's another minus here. So this is minus 1 over m root of minus x raised to power 1. Clearly you can see that it's not still the same thing. So as for the number 3, the function is neither even nor. Neither what? Neither even nor odd. So for the third function, neither even nor odd. So we have done this first one. This is it here. Let's show them. This is the first one, f of x minus 3. This one is odd. This is the second one. Please come. Second one, this one is also odd. But the third one now, we found out that it's neither even nor odd because it doesn't satisfy any of the conditions for the function to be even or odd. So we say it's neither even nor odd. Now to the last one. K of x equals to, let's do this one. Please follow me. K of x equals, that's the fourth one, under activity 2.3, question 1b, activity 2.3, question 1b. K of x equals square root of x minus 2 raised to power 3 divided by x minus 3. Square root of x minus 2 raised to power 3 divided by x minus 3. We want to find out if the function is even, odd, or neither even or odd. Now again, as we've been doing, for a function to be even, k of x must be equal to k of minus x. And for a function to be odd, k of x must be equal to minus k of minus x. So let's find k of minus x, and let's find minus k of minus x. K of minus x means that anywhere we see x, we put minus x. Anywhere we see x, we put minus. So this is going to be square root of minus x minus 2 all over minus x minus 3. Now everything here is raised to power 3, right? Plus, there is no way that they are the same, clearly. There is no way they are the... You see that this k of x is this, and this k of minus x, they are not the same. They are not the same. Class, are you aware that in mathematical terms, I can change this k of x to x minus 2 raised to power 3 over 2. The square root of a variable raised to power 3 is that variable raised to power 3 over 2. It's a rule in indices. So even if I still change this guy to minus x minus 2 raised to power 3 over 2, it's not still the same, all over minus x minus 3. It's not just the same. Now let's find minus k of minus x. Minus k of minus x, since this k of minus x, just attach a minus to this, whatever we have here. This is now minus into bracket, minus x minus 2 raised to power 3 over all over what? Minus x minus 3. You do not have to repeat the minus twice. Say minus for one, minus for that. No. One minus is enough. Class, as it stands now, it's still not the same. It's still not the same with k of x. And class, this minus cannot penetrate this bracket to even expand it here. Do you know why? Because this bracket has a power. Do you get? Class, if someone asks you to find, please, she should show it. If someone has to find minus outside 2 raised to power 3, please find 2 raised to power 3 first before you apply the minus, unless you have a different answer. Don't say, okay, minus, this minus has to be done with this 2, this 2 is done with this 3. Please, are you following? So, class, if someone can answer and say minus, that is minus 2 raised to power 3, class. Minus 2 raised to power 3 means minus 2 times minus 2 times minus times minus, plus times minus, minus. Now you might be lucky in this case, you might have the same answer, but not in all cases you have the same answer. You might be lucky in this case, you might just be lucky in this case, but it shouldn't be like that. Normally you should first deal with the 2 raised to power 3, then you now attach the minus. Very important. But either way, even if we use this minus to open this bracket, it will not still be the same as this. Because if you put minus here, minus times minus gives you plus. So it's now x plus x plus 2. And there's no plus here. So the function is neither even nor. The last function is neither even nor odd. The last function is neither even nor odd. Thank you very much. Watch out for activate 2.4. Don't forget to click the subscribe button. Thank you.